So the biggest update for me is just a reminder that we have our spring 2023 meeting coming up already. It'll be May 16 to 18 in person here at LASP, as well as online on Zoom, running around 9 a.m. to 5 p.m. Mountain Time each day. There's a link to the meeting's website and the email that I sent out as a reminder. If you have not registered yet, please do so soon so that you can get communications about the meeting and so forth, as I will not be sending emails blasting to PyHC all. Yeah, I think that's not a big overall thing that I had. Sean, do you have anything you want to let the people know before we start?
Maybe not. Definitely looking forward to seeing some people in Boulder this time. Meet a few of you in person for the first time. That'll be awesome. I'm trying to think. I'm going to be talking about our solar eclipse event at some point while I'm there at the meeting, and I haven't brought that up at a telecon in a while. So I've talked to a few people in this group individually about some things that we might put together for like a real-time display that would show like time series data streams that would be affected by the solar eclipse. But actually, a lot of the people I've talked to, I don't think are on the call right now. So I'll belay saying any more of that. I'll just talk about that later.
Sounds good. All right. Well, we had a couple different kind of more discussion-based topics today. The first one, I know, Brian, you have a conflict that you need to scoot off for whenever you can. So would you like to talk first about PyHC package publishing, that discussion we had the other day that seemed like it'd be good to bring up to the community?
Okay. Yeah, I'm happy to evangelize on this again. I think I have presented this before. Hello all, and if you don't know who I am, I work at NASA Goddard in heliophysics. I do a variety of things, but I come to you in the context of this conversation as someone who developed software for HelioCloud. What is HelioCloud? Can I share my screen? This will probably be easier
Sure,
here. All right, we'll just share this. So HelioCloud is essentially a framework for doing heliophysics research in the cloud. And at its basis is that every institution may deploy some part of the framework, and that framework enables the ability to talk to other cloud-based researchers in heliophysics. That's what these green arrows are. Okay, so that's wonderful. There are a number of components, and we hardly have time to talk about it, but what's relevant for this discussion is this piece in the middle here called the daSCub. And what the daSCub is essentially it's a Jupyter lab, right, that runs heliophysics software. And that's where PyHC comes in, because what we really want to do is we want that heliophysics software in Python to be PyHC projects, right? So that brings me now to the core of the presentation, argument, discussion. I'm not sure what to call it exactly, but that platform is envisioned as having 3 different levels of buy-in, and this also has hooks to other things like open science, which I also don't have time to go into here. But at several different levels, there's essentially the virtual software environment level here, the first level, where we essentially engineer a common environment. Now, I know Sean and others and myself have at various points come up with unified PyHC software environments. I don't know the status of all of them. I can only speak to the stuff I've been doing. And I can tell you that getting everything to run with the same dependencies is challenging. And in fact, it was actually impossible until I spent a lot of time on this last fall, a year from last winter, in preparation for the summer school, which was almost a year ago exactly from this month. And we got that working. It was a lot of effort. And I don't want to do that again as lone heroic individual doing that. I think this is something that's better taken on by this community, right? Self-policing, making decisions yourselves about what dependencies you're all agreeing on. There was stuff in there that prevented all of the core packages from being in the same virtual environment, like not allowing Numpy versions or something greater than X. And then, of course, somebody else's package needed X or greater, right? So you immediately have a dependency conflict. And so I think there are not only should there be an engineering effort in this community to do stuff like that as a group, but also the development of best practices like thou shalt not do that kind of nonsense. Also, it made it challenging to develop this virtual and software environment in common. Actually, I don't need to show the rest of this. I think that the need is right there, is that there were members of the community. So some members were in Conda and on Conda Forge or some other channel like AstroPy, and then some members were only in PyPy, and that this still exists today. And then some members were not even all the way on PyPy. They had to use the test PyPy server because they had some experimental packages. And for expediency for the summer school, I just sucked it up and said, fine, I will pull packages from wherever. And it worked, and we got it working, and that's great. But that's not really, in my mind, a best practice or a good idea. We shouldn't be relying on such a sort of scattershot process of deploying our packages. We should. My preference is that this community start publishing things perhaps on their own Conda channel, or maybe on Conda Forge, or whatever you deem is reasonable, all of your stable packages. And the advantage of doing that is that when I go to create a Conda lock file or just any Conda environment, it will do all of the dependency analysis and resolve the dependencies between all the packages. If some packages are in PyPy and I have to use pip to get at them, and some are in Conda Forge, which is the case today, then Conda will just barf back a message saying, oh, hey, I can't really resolve dependencies for these other non-Conda packages, so you're just going to have to figure that out on your own. And again, we're back to doing a lot of manual work. So yeah, poetry might be a solution. I don't want to prescribe particular solutions here. I just want to point out the current state of the art, if you will, and it's a problem. So in summation, if we want this community to have greater impacts, and it does have impacts, I don't want to make it sound like it doesn't, but if you want to continue to have your software be used by greater and greater audiences, we have to do the engineering to make it easier for that audience to use the software. If we believe that our software works well with other packages in PyHC, then we should do the upfront work to help our community out by engineering it. And there are two major use cases. If you believe your package is a standalone army of one and will never be used anywhere else, that's silly. I will throw out these two use cases that exist now. Number one, the HelioCloud, where we absolutely want to have an online analysis environment where things quote unquote just work. Our users don't have to sort out the dependency hell, and they can just go in and feel confident that the stable software from PyHC is going to work. And they don't have to do that engineering, and that they may layer on additional packages that they want, but that basis is there and it works. And another use case is for open science. If you're not familiar with open science, again, I don't have time to dig into all the details, but I'll just summarize it as the goal to make our science reproducible and transparent. And part of that transparency and reproducibility is publishing the software alongside the data and the paper itself. And so now you can anticipate how this hooks into PyHC, in the sense that if somebody's publishing their software for their paper, we want downstream users to more readily be able to use that software. And how do we get there? Well, we could develop best practices, of course, for the publishing of scientific software, such as thou shalt have a virtual environment declared and available for it. Aha. So we're right back to what I was talking about. And wouldn't it be wonderful if the basis for all those virtual environments was one that was well engineered by the PyHC community that can then support open science and downstream users? There's obviously a lot of details here that I'm glossing over and whatnot, but I believe the time has come. I guess I am basically throwing this challenge out to this community that they take this on and they work on this. Of course, I'm not just throwing something over the wall. I'm happy to participate and work with this community on this, but I can't do this alone. HelioCloud cannot do this alone. It really should come from this community. So I'll stop right there.
Yep, thank you, Brian. This is one of the more foundational reasons that PyHC exists in the first place. So it's an important thing to think about here. I will mention that we're going to be having a kind of hackathon at the spring meeting around this, maybe just so that you don't feel like you're the only person thinking about it, for one, but also to get people's minds mentally prepared. I made like a little spreadsheet basically with like this little Python tool that I put together with the help of ChatGPT, fun fact. It looked at the pip dep tree dependencies for every PyHC package. So it didn't capture some things like, I know like SpacePy, for example, uses like a Fortran compiler and it wasn't catching dependencies like that. But I have this spreadsheet of like 55 PyHC packages and a list of package versions for all of like the 156, I think, dependencies that are required for every single one of them, if you just like list them out recursively. And there's technically allowable versions in there that should work. So, you know, the main goal, the eventual goal is to get to a place where we have one PyHC environment that either has all the PyHC packages or a large number of them, like 55 of them. And then at that point, it starts to become a rule that, you know, to play nicely with the community, you should talk to us before you add something to your requirements.txt file that, you know, breaks that compatibility, etc. You got a hand raised?
Yeah, no, I love it. I think though you're going to have to go further shortly after that, and the community is going to need to have some kind of CI/CD like approach to this, and everybody needs to have some unit tests on their software base, because it's going to be too hard to do the dependency engineering. And you should plan policy-wise for a situation where packages, even if they're core packages in the out years, become abandoned or less supported or not supported. And then the community has to have a decision point there about, okay, how important is this package to maintain? We don't have any support for it, yet its dependencies are so out of date with what everybody else wants to use. What are we going to do? And it could be that it's easy to engineer and just sort of update those dependencies and everything works fine, but without those unit tests there, you're not going to know that. But there will come a day, now speaking apocalyptically, there will come a day when what were formerly core packages will have to be abandoned or downshifted simply because of the lack of support. But this is normal and natural if this is to be a living community. We can't be chained necessarily to folks who are not maintaining their software. So that's another aspect of this. I'm sorry to drag this in a variety of directions, but that also will come up as an issue.
Yeah, and before I let that point disappear and I ping you, Gavin, to say why you raised your hand, I will say that one of the first measures that we have, like a CI/CD kind of thing, like one of the first ideas we have for that is the PyHC gallery, which I've kind of put a pause on putting out the new Jupyter book version that I built like with Ashley and a couple other people. But if we get actually a pretty good like PyHC environment, quote unquote, out of this little hackathon at the spring meeting, I think the idea was to publish that on the PyHC gallery and have that be part of its CI deployment. So like as we add examples to the gallery, or just maybe on like a timer, it'll pull in the latest versions of packages and do a check to see if the environment is still valid or if there's been a new dependency conflict that got introduced. And that would at least let like me know, if not anyone else, like if that job broke, it would let me know that there was a problem and I could go talk to like the developers of the package that made the problem. But yes, Brian, I agree that a more centralized solution that was more like, hey, run this PyHC unit test suite every time you do something would be a prettier solution and something to move forward to.
Yeah, I agree. Rebecca, sorry, brought up a good point about, just building an environment in general with all the PyHC packages installed. And then, each new and current package that remains has to be compatible with that and to update it every year. And I feel like that could be part of your responsibility, Sean, but also maybe this speaks to just a need to get more people on the main PyHC board to work on this. My territory.
I'm going to have to drop soon, but poor Gavin has had his hand up. I'd love to hear what he's saying.
Yeah, I was just going to say, I think, I hear what you're saying about going the CI/CD pipeline route and really keeping it like kind of monolithically focused around PyHC. But I think you can, the open source Python community at large has pretty much achieved that by just establishing best practices around supporting as broad of supported packages as you possibly can. So, make it a requirement that you support every currently stable Python version, and maybe just make sure that if you're supporting NumPy, you support all the stable versions of NumPy for each of those stable Python versions. And just kind of, if you continue that out, in theory, you really won't have any problems. And you can kind of do that from a more foundational perspective instead of like glomming everything together. Although that test is obviously a good test of that.
Makes sense.
Yeah. Kind of along those lines, NumPy enhancement proposal 29, which I put in the chat, lays out a deprecation policy. So it's essentially to support versions of Python that have been released within the past 42 months and versions of NumPy that have been released in the last 2 years. So I think that would be a good place to start for a community policy. We should at least be consistent with this, since this is what Plasma Pi follows.
That's a good point. Thanks for bringing that up, Nick. Thanks, Brian.
And NumPy is not a bad example to focus on, because I was talking about that table of dependency versions that I had made. NumPy version 1.23.0 is the only minor version of NumPy that could be allowed if you chain together all of the different rules for the greater than this version, less than this version for all of the packages I had in that table. So yeah, having just exactly one NumPy version that works is problematic.
Yeah, NumPy itself is NumPy itself is really stable, so we generally shouldn't be putting an upper limit on NumPy versions anyway.
No.
Agreed.
But NumPy might put upper limits relative to other packages, right?
True. Something to think about more. And admittedly, part of the reason for bringing this topic up was an excuse to advertise about the hackathon at the spring meeting, where we'll be able to talk and think a lot more about this.
Another thing that'll bring a lot of awareness to developers and users about this is using environment managers that actually solve the dependency tree. I think a lot of people use Conda, and then whenever they have a problem, they just default to pip. And the reason that they're having a problem is because Conda is refusing to solve that dependency tree, because the metadata in one of their packages is either poorly formed or they have weird requirements in there for versions. And a lot of people end up just installing things with pip, and pip is totally happy. Well, it's getting a little bit better, but in the past, at least, it was completely happy to just install whatever version. It didn't even check the metadata. They're starting to do that a little bit now, but pip still doesn't do a full dependency tree solve as far as I know. The only two tools I know that do are Poetry and Conda, but unfortunately they use completely different metadata standards. Poetry is a little bit more in line with the rest of the Python community, and Conda is just like over in left field at a completely different metadata packaging standard.
Sean, would it be possible to take your analysis of packages and put that online somewhere and sort of maybe have warning flags of like, you know, these issues are, or sorry, these packages are close to being in conflict, rather than enforcing, you know, standards at the moment. I think like some information might be useful.
Yeah, I agree with that. I haven't thought through all of the things I could do with this information, definitely. But one thing that I have thought about is that this little tooling that I wrote to automatically generate this spreadsheet is a Python tool. And I was going to make it a PyHC package at some point and start recommending that people like, you know, use it. It's not a mature thing, but it's a little Python script that can generate you a nice table to help with this kind of thing. So yes, I was going to try to get that in front of more people, especially after using our little hackathon at the spring meeting as kind of like a first test run to like make sure, hey, the versions that it's telling me should work, do they work? Yeah.
Okay.
Any more thoughts on this subject before we move on? Awesome. Well, we will definitely be thinking more about this and coming back to it. So don't let this topic go completely from your mind. So the next thing we had up for today was to have Gavin come and present about his packet parser package, which has recently now been published, and it has a new name and everything.
Yeah, I apologize for any confusion this generates, but so I think some of you may have heard me talk about a package called Last Packets that I was working on for the last couple of years. That package has gotten pretty mature, works pretty well, and so I moved it to GitHub, renamed it because there was a conflict with Last Packets on PyPy for some reason, and open source licensed it, added some better testing and things like that. So I just wanted to kind of give a little update on that and give a quick demo. So this is the documentation. It's automatically generated from GitHub. It's on Read the Docs. Unfortunately, the SEO on this documentation is not super awesome. So if anyone wants the link to it, I would be very welcome. I did just submit a pull request in HelioPhysics GitHub IO repo, or PyHC GitHub IO repo, to include this as one of the listed projects in there. It's pretty well tested. It's pretty well documented. The documentation's automatically generated. The tests automatically run. Pretty good code coverage. And it's a pretty robust package that a lot of people are starting to use, not just in heliophysics, because this just kind of applies to CCSDS packets, but on planetary missions as well, and Earth observing missions, and really anything where scientists need to decode CCSDS telemetry packets. So these are kind of some example use cases. Is my browser big enough for you all to see?
A couple zoom ins would help, I think.
All right, how's that looking?
I can read that.
There. Okay. So essentially you open your packet file, you open an XTCE document that describes your packet definitions. And I say definitions plural because you can have many different packet definitions in a single XTCE document. And this packet parser will actually happily parse muxed app ID streams. So if you have housekeeping, maybe a couple different science app IDs, and you need to parse all of those out of a single file because of the way that whatever data center generated it, delivered it to you, it's very happy to do that. Also, if you're missing definitions, you can control the workflow so that it just skips the packets that it doesn't understand, and it uses the CCSDS header information to skip to the next packet based on the documented packet length. So it's pretty robust to that kind of behavior. you create a packet definition object. This basically creates a packet inheritance tree where, depending on how you structure your definitions, it can actually do all kinds of complex packets that show up in science all the time, like polymorphic packets, where you have a different set of fields based on a switch bit early in the packet structure. It can do variable length fields. It can do variable length strings via termination character, via an integer at the front. It can do variable length packets that just fill the rest of the packet after the fixed length fields are already parsed. So it's very flexible in that respect. The only caveat there is you have to know a little bit about generating XTCE. If that's a barrier for anyone who wants to use this, I'm pretty dedicated to supporting my users here. So please let me know if you have trouble generating XTCE for your program. Usually people in that position have Excel spreadsheets that they need to generate XTCE from. The problem with Excel spreadsheets is that it's really not very programmatically readable. XTC is very robust and is a full description of packet definitions. So let me know if you have trouble with that. You then create a packet parser object. You can open the packet file as binary data, and this is a bug in the documentation I'm about to fix. You have to open it in binary mode. So this should have an RB in here. Then you create your packet generator from the binary data, and then you can iterate through your packet generator. Now, under the hood, the way that this works is it actually reads only chunks of the binary data at a time. So it does not load the entire file into memory. It used to do that, and we realized it was very memory inefficient. So we now actually iterate through the file until we get enough data that it constitutes a full packet. Then we feed that packet into the individual packet parsing routine, and generate a packet. And there's all kinds of good error handling in here that you can control with your arguments to the generator. So you can have it return incomplete packet objects if it fails to parse, and then you get the kind of incomplete parse data. Usually that happens as you're working on your packet definitions. You can have it raise exceptions if it encounters packets it doesn't recognize. You can have it skip those exceptions. You can have it totally silently skip those exceptions if you want. So a lot of control over how this handles different error cases. And then you get your packet.header and packet.data as an object. And that essentially is a dictionary-like object that is very not opinionated. So you can use lambdas to filter that kind of data based on app ID, based on other fields. It really leaves it to the user how you want to use this. And again, our emphasis here is on memory efficiency. So we use a generator so that you're never forced to read all the packets into memory. And again, we use this kind of incremental parser so that we don't actually have to read the entire binary file into memory at any point either. And that brought a lot of our parsing from like 130 megs of memory use down to about 16 megs of memory use peak. So that was a pretty big memory improvement. There's also a little bit of support with it for a CSV packet definition. I can't really speak to how long this will be around because these CSV files that describe packet formats are really unstable and kind of bespoke depending on what organization you work on. I would not really recommend using this. I would definitely recommend using the XTCE based parsing. All right. Any questions so far? Yeah, Rebecca.
Yes, I do. Okay, so if I'm trying to scroll up on your screen, that's so funny. Okay, so if I follow correctly, this is for parsing packets that presumably come from a satellite in orbit. Do I follow that right?
Yeah, I mean, it doesn't have to be in orbit. Just any spacecraft pretty much generates CCSDS telemetry packets to downlink science data and all data, really.
Have you tested this for packets coming through different companies? Say one coming through, I can't think of the company names now. One coming through, say, Blue Origin, and another one coming from Blue Canyon. Have you tested this against different formats?
So as long as they are adhering to the CCSDS standard, this package will work.
So how global is that standard? How widely adopted?
I mean, it's the basis for pretty much all European spacecraft commanding, all spacecraft and instruments that LASP operate downlink CCSDS packets as of about a decade ago, I think. It is the basis for Cosmos planning and scheduling and commanding software. I think it's also the basis for Oasis, which is the software we use at last for planning for like real-time operational packet parsing. It is a widely accepted standard. It is the international standard for how packets are structured that come down from spacecraft, and actually command packets going up as well.
Gotcha. That really helps. Thank you.
Yeah, I think I see where you're going though, which is that XTCE is an XML format, and that's maybe not the most appealing. I get that people don't like working with XML, but in the absence of anything else that is as functional, I chose to go this route. I mean, I have explored a lot of different ways of representing packet structures, CSV, Excel files, database schemas, SQLite database files. What else have I seen? Different custom XML formats, dynamic in Python hard-coded form specifications, and not a single one of those is actually capable of representing the complexity of packets that XTCE can handle. So I'm pretty convinced that XTCE is the way to go on this. I mean, someone put a lot of thought into designing the XTC UML model, and it works very well. And as far as I know, CCSDS is really the global standard for this. And someone put in the chat about the CCSDSPy package developed by Daniel daSilva. That's a great package. He and I pretty much have similar use cases. His is not based on XTCE. So for his, if you want to, if you need to specify the packet structure, you have to do it in the Python code. I chose XTCE again because it's a really efficient transfer format, and our flight software engineers can usually export XTCE documents from our command and telemetry databases, and it usually requires a little bit of alteration before it works, but it's a really good starting point, and it saves me a lot of time. The other thing I'll mention is I think we have a pretty different APIs, and we support slightly different levels of complexity with our packets. So Space Packet Parser can represent pretty much all CCSDS telemetry packets, not command packets, but telemetry. And I think Daniel is still working on supporting some rather complex, for example, polymorphic packets. See, John has a question about JSON for representing packet structures. That seems like a great idea. There's just no schema for it, and I'm not in the business of inventing standards to make more standards. I really like just using stuff that's already out there that works really well. I don't find XML to be particularly onerous, at least not more onerous than JSON. It's just another format to read, so I stuck with it. But I could totally imagine someone inventing a JSON standard that maps to the XML standard for XTCE. I think it would be a heck of a lot of work, but that's kind of where we are at the moment. And as a follow-up question, you asked, are there tools for making the XML content? Text editors work really well, but for a real response, I don't have tools there right now. And part of that is because every flight software team generates these definitions in different ways, and trying to write a tool for something that our flight software engineers generate, for example, an Excel file, the chance of that working for anyone else is pretty much zip, because these are all like the way that these flight software teams generate their packet structures and their definitions outside of XTCE is completely non-standardized. In fact, we have different flight software teams at last that do it differently, which is extremely frustrating. So I haven't put any time into building that kind of tool. I didn't think it would be particularly generic or useful for the community. But again, I recommend, if you want to use something like this, I recommend asking your flight software team if they can export XTCE, because again, it is a standard. Anyone who kind of complains about that, I encourage you to ask them what their standard is and whether it can support all of the same functionality as XTCE. A little tongue in cheek. I'm pretty convinced that XTCE is far and away the most complete representation of telemetry packets. I haven't seen anything that even comes close. All right, so I'll show a quick example here. Can everyone see my pie chart window? Is the text big enough?
You could make it just a little bigger.
Okay. Okay, So
Yeah, I can read
this is
that.
an example. This is an example where we are going to be parsing data through a socket, kind of mimicking how this packet parser tool might work as kind of the basis for a quick look tool during integration and testing. And this kind of illustrates the actual parsing of packets, the visualization of that data, and also how we can support a diversity of different data sources. So essentially, we can support a fully read binary file. We can support a binary IO reader, like buffered reader object in Python, or we can support a Python socket. And all three of those work transparently as data sources to the generator call in space packet parser. So if we go down here, you can see we are reading in the XTCE definition for this science packet. This happens to be for IDEX. It's the same definition for SUDA. I know that's not really heliophysics related, but these are just CCSDS packets. It's all the same standard. Then we create a packet definition from that XTCE document. That packet definition gets passed into a packet parser. So this packet parser is now ready to read some binary data. It's primed with the packet definition already. And that only has to happen once. So read the definition one time, parse lots and lots of binary data. Here's a packet data file. This contains some CCSDS packets from a test that was run. And IDEX packets are really complicated. They have a behavior where if one of the bits is, or if one of the integers early in the file or early in the packet is set to a number greater than 0, you get a totally different packet structure after that. So I call these polymorphic packets, and I can kind of get into that more if people are curious, but I'll just say that that's a pretty complex packet structure. Most telemetry packets are not that complicated. Let's see, so here I mimic a socket sender and receiver pair. So the sender in real life would probably be an instrument undergoing some tests, but the receiver socket would just plug into it. So here I'm kind of mimicking that, and I kick off a process, a child process from Python that just mimics an instrument sending the data. So I parse the file and then just send random numbers of bytes through the socket for our socket receiver to grab that. So then I create a generator object with the socket receiver object. So remember I said we could use a buffered IO reader, a completely read binary file object, or we can use a socket. In this case, we're using a socket. And the reason I did this in the example is because it's by far the most complex case, because I wanted to illustrate that. So here's some logic for actually parsing the data arrays in the packet. We're going to skip over that, and I'm just going to run this to show you kind of how this looks. Okay, so you can see the sender is saying, I'm sending this many bytes, now I'm sending this many bytes, now I'm sending this many bytes. It's just sending random numbers of bytes to the socket connection. And this is to test that the reader is robust to incomplete packets coming through. Basically, the generator waits until the socket has sent enough data through that it can parse a full packet, and then it immediately parses that full packet and then waits for another full packet to come through. You can see, okay, we just got a full packet, we're parsing a waveform for a psi type 2. And if we go over to the plots, we can actually see these plots get generated. So these are plots of different channels in the data. And you can see as packets come through, we generate more plots. So this is kind of and this example, by the way, is in our GitHub repo. And I put this here because it's basically a basis for writing a quick look tool for any kind of data. And then at the very end, you'll see we get a timeout message. It says the source timed out, and that's because our socket receiver has a timeout on it that waits for data to come through. But since the sender was done reading the data, it stopped sending it. Eventually, the other end timed out, and this is expected behavior. Okay, I'm gonna go back to the chat here real quick because I see some traffic. How do you handle receiving partial records? For example, when a signal lock is lost mid-transmission. Okay, yeah. So, well, I want to expand on that a little bit. So you're talking about transmission from a spacecraft when we downlink, and typically ops handles that kind of like CRC forward error checking and read Solomon correction. So they do a lot of QA QC on these data before they actually get packaged into binary files and sent on to science data processing. And that workflow is pretty typical, at least at LASP and at NASA data centers. So for example, Goddard, like EDOS at Goddard, they do all of that kind of work for you. And then you just negotiate an interface with them to ask them for the packet streams that you want. And you can specify which app IDs you want lumped together, whether you want every app ID separately. You can specify the time, like whether you want 2-hour files, daily files, or 1-hour files. So you can kind of negotiate that interface with whoever's providing your data. But by the time L0 binary data gets published, it is usually totally complete, error checked. You'll never get partial packets. That said, as long as the number of bits following the CCSDS header actually matches the packet length in the CCSDS header, this library is extremely robust to those kinds of errors. If, however, you have a packet that is the wrong length relative to the length specified in the header, that's going to be a problem pretty much no matter what. There's nothing in CCSDS that really allows you to go like in a random section of binary stream. There's nothing that really allows you to go find the beginning of a CCSDS packet. And so it's really difficult to avoid a hysteresis problem where if you get one incorrect packet length, everything after that is kind of blown. And I see, Rebecca, you have your hand up again.
Yeah, I hear echoes from my HaloSat days in astrophysics. And the guy next to me shouting quite a length of curses about this entire process.
Yeah.
But the problem that irked him the most was when he got repeated packets from previous days.
Mm-hmm.
And some of them were already in his database and some were the ones he was looking for. Does this package help solve that problem?
No. However, I would say that is kind of outside of the scope of science data processing and even outside of the scope of CCSDS as a standard. I mean, if you are having problems with duplicate packets, it's really up to your flight software team to make sure that they are implementing software that allows you to uniquely identify observations and packets. If they're not doing that, that's the problem with the way that the instrument software has been implemented. At least that's how I would cast that, because if you can't uniquely identify a packet, for example, by its source sequence counter and timestamp, that's kind of a standard way of doing that. If you can't uniquely identify it that way, you're kind of stuck. Like the information's just not there. And CCS doesn't mandate that information be there, but your flight software team should be implementing that kind of stuff, in my opinion.
Thanks.
Let's see, John, another question about cloud environment, possibly reading from S3 instead of a file system. If the chunking mechanism is flexible and cloud with fewer larger reads, this would likely help, I think. Let's see, it is compatible with S3. So on one of the projects I'm working on, we essentially have a wrapper for an S3 object that allows us to read it into Python as if it were a local file object. It pretty much makes that transparent. And that's using a library called CloudPathLib under the hood, which plugs into Bodo and all of the standard AWS SDKs. So we have kind of a wrapper around that. And this library works just fine with a binary IO object generated from cloudpathlib.open. So I know that there is at least works with S3. The one thing I haven't done though is examine the kind of memory footprint and performance when it's reading from S3 as opposed to a local file system. So that's something we could definitely check into, but at its absolute base level, it does work. Does that answer your question, John?
Yeah, thanks.
Excellent. Okay, what else did I want to plug here? Yeah, okay, so in the vein of what our previous presenter was talking about, we try to be really open about the versions of things that we support. So we have two core dependencies, Python and bitstring. And bitstring is just it's the library that we use to kind of iterate through and parse binary strings into integers, floats, et cetera. And we try to be really open about the requirements for that. 3.0 is kind of when that library became stable and the API stops changing. And 4 is the most recent version. There is no version 5. So we support everything greater than version 3. I just have the less than 5 here just in case there's a breaking change between version 4 and 5. And then for Python, we support 3.8 through 3.12. I already chopped out 3.7 because 3.7 is end of life really soon. And I looked that up. So 3.7 is end of life, end of June. So I figured I would preempt that a little bit. I could have waited till the end of June, but didn't want to sign up for extra maintenance tasks just to have a couple of months support for a really old Python version. So I think we're doing a pretty good job of supporting open dependencies. We also do provide metadata for our dev dependencies. These I don't worry too much about compatibility with others because probably if you're installing these dev dependencies, you're only installing this package to work on it. So this kind of matters a little bit less, but we run our PyTest tests randomly in order, in a random order. We use PyTest. We use Sphinx for generating documentation in coordination with read the docs. We use coverage, and I was just looking at the coverage report. I actually need to add some coverage to certain recent stuff. And then for the examples, I even have a dependency group that Poetry can read to give you the dependencies required for running the example that I just ran. Because obviously we don't want MATLAB as part of, or memory profile as part of the core dependencies. Let's see. In the repo itself, we have a pretty solid base README in addition to the read the docs user documentation, which includes a full API reference that's automatically generated. So you can look into the parser. Probably where you're actually going to want to look the most is in parser.generator. This is where most of the interesting stuff is. So we have pretty good README. We have good documentation. We have a BSD3 license that's on the advice of our CU lawyers. We have a code of conduct policy in here. We have a citation that you can export as APA or BibTeX. And the way that we release is by merging dev into master, tagging it, building all the documentation, and then merging whatever the release branch was back into dev. So essentially we use the Git flow workflow where feature branches merge to dev. Occasionally for a release, dev merges to master, and then master gets tagged as the release version. Okay. I think that's about all I got. More questions in the chat? Nope. I'll leave this on the documentation page because it's pretty. All right, that's all I got for this. If anyone has any questions, please let me know and I'll put my email in the chat so you can contact me. Also, if you have issues using this library, please open GitHub issues. I'm committed to responding to those.
Looks like you got one more question in the chat.
Oh, are the releases automatically uploaded to PyPy when you tag it? They're not automatically uploaded, but I upload them within a few minutes. And that's a level of automation that I am very happy to look into. It's one of those things that's kind of, it's a nice to have, but really not crucial. And I have a lot on my plate right now, so not really looking for extra stuff.
Understandable. I don't have a question, but just something to point out to all. Gavin has recently submitted this project to be part of the PyHC ecosystem. So just an FYI that I think that PR is still open on our GitHub, but excited to have you be part of the community.
Yeah, we're gonna understand.
And speaking of that, Gavin, did you see like the one comment that I left on it? On the PR?
About the badges?
Yeah.
Yeah, I updated that within about a minute of you putting that comment out there.
Oh, that's hilarious. And then I didn't go and look at my inbox. So cool. You're on top of it.
No worries. I was working on it anyway.
Awesome. Any final questions? Cool. Thanks for the email and thanks again for presenting on all the updates you've done since the last time we heard about this, Gavin.
Sure. And I think I'm going to drop off.
Fair enough. All right. Well, I mean, I think we're at the end of today's agenda as is anyway. So I'm going to go ahead and wrap the meeting up in general. We will not have another telecon to my knowledge before the spring meeting happens. So I'll see you all at our big biannual event. Some in person, some online. Looking forward to it.
Thanks, Julie.
Thanks,
Thanks.
Rebecca.
Bye.